Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, March 27th. Looking at significant wave heights for the North Pacific Ocean, we see a broad gale just about over the dateline, generating almost 33-foot seas, aimed reasonably well at Hawaii, and less so at the U.S. West Coast. Otherwise, no activity of interest is occurring. Let's get into the details. First, we'll take a look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales do form, help direct their track. We're looking for troughs, that is a dip in the jet stream, like right there, that would help support counterclockwise flow aloft and also down at the surface, and that is the hallmark of low pressure. And low pressure, of course, generates winds. Winds generate seas. Seas, when they radiate away from the fetch area, generate swell, and swell eventually creates surf when it impacts coastal regions. Nice trough here with 200-knot winds blowing into it. Also notice, though, a heavily split jet stream once you get past, about the dateline or so, with the northern branch here running almost up into Alaska and the southern branch into Mexico. A little bit of a trough here. This might help support a backdoor trough in a day or two over the U.S. West Coast, not generating any surf, but perhaps maybe some cooler air and some precipitation in the Sierra. But otherwise, a good, strong, consolidated jet from about the dateline westward. Let's put this into motion. Roll this out. This trough falls southeast into Monday and even Tuesday, looking pretty good. Then starts to pinch off later Tuesday at a point, what is that, about 900, maybe even 700 miles north of Hawaii. And let's see what happens. Notice this ridge builds way up into Alaska, too, and here's that backdoor trough. In fact, let's go back just a little bit. So here we are Sunday night, and just watch this. It's sort of inland, and then it just barely peeks out off the coast. It actually doesn't even do that into Tuesday. And there you go on Wednesday. That would usher in colder air coming down from inland Canada. And probably maybe squeeze a little bit of precipitation south of there, but nothing much. And then again, the jet stream again does this big ridging thing. So the U.S. West Coast, for the most part, is cut off from moisture and cold air. But then we still have a consolidated flow into Thursday, but not as strong as it was before, with winds only in about the 120-knot range. That continues for a while. Another trough here tries to develop. But notice most of the winds are in the southeast quadrant. You really want the winds pushing down into the trough. That's what really generates the best opportunity to support swell production. That trough continues. We go out 180 hours, and it sort of tries to organize a little bit better, but just the winds are not particularly strong in the jet at this point. Also, though, we're consolidated. The jet is consolidated, started to push into the U.S. West Coast, too, with another trough about a week out, supposedly, off of the Pacific Northwest, and 130, 140-knot winds pushing into it. Maybe a little bit of support for gale there. But overall, kind of a lackluster pattern. Nothing particularly intense indicated. The suspicion is that is because the inactive phase of the Mjo is over, at a minimum, the Eastern Pacific, over the Western Pacific to about right around in here. The active phase of the Mjo is trying to organize, but not supposed to make a whole lot of progress. But we'll get into that in a minute. Let's go down to the surface. And here we go. Surface level pressure, surface level winds. Pressure here about 968 millibars in this gale, with 40-knot winds out of the west-northwest, taking pretty good aim on Hawaii, a little bit at the U.S. West Coast. Also notice high pressure here off the U.S. West Coast, with the jet stream running like this, forming a trough here, and then splitting up here and up here. High pressure, of course, would be expected under the split, low pressure in the trough, so everything appears to be about as one would expect. And looking into Sunday night and Monday, the trough, the gale continues 40-knot winds aimed almost directly at Hawaii and falling southeast with into Tuesday 30-knot winds, just barely. And here's the fetch from the leading edge of the front, 15-knot winds, just making it over Kauai and almost reaching Oahu. And then into Tuesday, and then the gale pretty much fades out, winds 25 knots, and you're not going to get much other than maybe 11-second period wind swell out of that. The gale continues to rotate there in the Gulf of Alaska, but just not having enough energy to really do anything. Another gale tries to move in, not even a gale, low pressure cell, on Friday night, trying to get organized, 30-knot winds, and that's a week out and nothing more, and then that's pretty much it. And then yet another little system trying to organize a week out off the U.S. West Coast, but weak winds, just the whole pattern not particularly energetic, again attributable to a weak MJO signal. So next we take a look at the effect of those winds on the ocean surface. Clearly we see 32 foot seas, basically 31 foot seas right here on the date line. Again, aimed pretty well at Hawaii and somewhat at the U.S. West Coast. And this is as of 12Z Sunday. That fetch falling southeast, 32 foot seas into Sunday night, and Monday pushing over the date line, just pushing directly at Hawaii. That's where the lion's share of the fetch would be, with energy starting to sweep over the Hawaiian Islands come Tuesday into Wednesday or so, and even into Thursday, but then things dying off. You can also see the swell front starting to move its way towards the U.S. West Coast, but much less energy is expected there and size-wise, too. And then we roll out. We don't expect to see anything until we get towards the later end of the model here, and we see a tiny area of, was that maybe 19 or 20 foot seas on Sunday. That's a week out. April 3rd off the U.S. West Coast. Another one trying to develop on the date line, but again, just not a whole lot going on, not enough support from the jet stream, and change of seasons and the MJO all sort of fighting against it to a certain degree. But that's sort of it. And we'll take a real quick look here. Also, swell angles relative to Hawaii. What's that about? The 319, 320 degree track right there. And we see here's our fetch developing. This was on as of Saturday, and right on about the 319 degree track, maybe 317, and there you go, maybe 314, pushing into Hawaii and moving very close to the islands. Probably a bit of wind and a bit of raw quality to the swell when it arrives. And then relative to the U.S. West Coast, we'll watch the same thing. There's the 296 and there's the 292 degree tracks there. You see this system is really almost cutting across those tracks. There is energy pushing up them, but not nearly as much at Hawaii. And it goes anywhere from 296 down to 280 degrees or so relative to Northern California, and much the same for Southern California. So not really much energy. Most of the energy is pushing Hawaii or out in this area here, so not a whole lot expected for the U.S. West Coast. Then we'll take a quick look at the South Pacific, and we're actually going back in time a week ago, Sunday, March 20th, and we'll just do a quick examination. There was this one gale here in the deep South Central Pacific, 38-foot seas on Sunday the 20th. That should push some sideband energy up into Southern California about 9 days out or so. But most of the energy is targeting Peru and Chile. And then there was some secondary energy there as well. Now, there was this other system also on like Monday, Tuesday that was tracking under New Zealand. But as best we can tell, it was going either straight east or almost southeast. That means little energy for Hawaii and probably not a whole lot for the U.S. West Coast either. Now, all these seas in the 26-foot range, that only generates about a 14-second period swell, which decays significantly on the track up to the U.S. West Coast, so we're not expecting anything from that. And that was about it for the past week. And then we'll take a look at the forecast for the South Pacific for the coming week, and we'll just blast right through this because the expectation, there's this little bit here forecast, was that 30-foot, 32-foot seas on Wednesday. That certainly will create swell for Tahiti and maybe a little bit of background energy for Hawaii. But other than that, there just isn't a whole lot on the chart. So that's it for the coming week for the South Pacific. So swell-wise, it looks like the lion's share of the swell is being generated now in the northern hemisphere, pushing towards Hawaii, again with sideband energy for California. But after that, not a whole lot forecast. Let's go take a look at the long-term picture. So here we are. We're towards the end of the core El Nino season for this, the 2016. We'll call it strong El Nino, certainly not a super El Nino. We'll dig into the details here, see what's happening with our El Nino. But the short of it, things are slowly fading out. In a normal year where we're at, you'd still consider things pretty impressive, but we're on the tail end of it all now. First off, we'll take a look at westerly winds, or we're looking for the presence of westerly wind, not even westerly winds, westerly anomalies in the area here. We call it the Kelvin wave generation area, from about 135 east to about 170 west and 5 degrees north or south of the equator. West winds in this area suggest the active phase of the MJO, and the active phase of the MJO tends to goose up the jet stream, consolidates it, makes it stronger, and therefore supports storm development in the North Pacific during winter months. We see little bits, hints of weak westerly anomalies, but most all of this here is well north of, well, let's see, there's 10 degrees, so it's north of the Kelvin wave generation area proper, and we just look here through the past couple of days, and that pattern's pretty much held through the 25th of March. And then the current image from the TAO buoy array, actual buoys on the ocean surface, suggest easterly trades over the whole North Pacific, and the Kelvin wave generation area is right in here, this area right here. You can see bits of westerly winds, but most of that's almost south. There's 5 south, so it's right on the southern periphery of the Kelvin wave generation area. Anomalies, actual differences in normal for this time of year. Clearly we see weak westerly anomalies in the Kelvin wave generation area, but just barely. Most of it's actually east of the Kelvin wave generation area, so therefore it won't have as much of an impact on the jet stream as it optimally would if it was more back in this region. If anything, we're seeing easterly anomalies in the western Kelvin wave generation area. That's not unexpected given where we are in the El Nino life cycle. This is the beginning hints of a La Nina starting to shape up. And here's another way to look at it. Here's the Kelvin wave generation area proper, the core of it, 3 north and south, the outer extremities, 5 north to 5 south. Date line right here, and this per the GFS high-res GFS model, and clearly we can see some westerly winds, just a small patch right here. What is that, in about the 18 knot range? But for the most part, there's your trades over the northern portion, and just sort of a north-south flow elsewhere, or dead calm. We'll roll this out, and even these westerly winds here fade out come Monday, and then we're just sort of left in a neutral flow, if you will. Dead winds for the most part here. What is that? Oh, roughly 6 knots or less. That's probably good for weak westerly anomalies. That is, lack of any winds at all are the same as what would be a westerly wind pattern, because normally you have trades in this whole area out of the east. So no winds suggest a drift from west to east. We'll roll this out, and we're just looking. We don't, you know, here comes another batch of easterly winds, but mostly calm winds in this region. So El Nino is still definitely having an impact on the atmospheric weather pattern, but not super strong, not super pronounced. And yet one more view here, the date line running right down here. This is the whole planet on one chart, going back in time towards the present. These oranges, reds are westerly anomalies, if not out-and-out westerly winds. So this was the tail end of westerly wind burst number 6 that went through about March 8th. It faded out. Here we go. We have the start of westerly, I guess you could call it westerly wind burst number 7, but not really. It's very weak, not strong enough to even be qualified as a westerly wind burst. And then here's the week-long GFS forecast, as we saw. Little patches of westerly winds, but nothing really strong. And actually, easterly winds, easterly anomalies forecast come April 2nd here on the date line. So the whole point of these westerly winds, normally what they do are westerly anomalies. They take warm water that's in the West Pacific, push it off to the east in the form of a Kelvin wave. That is a batch of warm water, a pocket of warm water that travels under the equator west to east, hits the Galapagos, erupts to the surface, and creates a warm water slick there. That is the hallmark of El Nino. But there is no warm water under this area where the west winds are occurring now because of 5 successive Kelvin waves or more that have blown through during this El Nino, pushing all the warm water there is left in the West Pacific to the east. So that's typically how El Nino decays and falls apart, and we are in that cycle now. Still, even though we can't get any Kelvin waves, westerly wind bursts or westerly anomalies are normally a sign of the active phase of the MJO, and regardless of the water temperatures, westerly winds in the Kelvin wave generation area right here help support the jet stream, make it stronger, and also help to support storm development in the North Pacific in winter months. The blue here, this is outgoing long wave radiation, sunlight reflectivity off the ocean surface. Blues suggest, you can see the scale here, less sunlight reflectivity, negative numbers, suggesting the active phase of the MJO. Oranges, yellows suggest high pressure, the inactive phase of the MJO, more sunlight reflectivity off the ocean surface. And so the current setup is weak active phase over the dateline region, inactive phase over the Indian Ocean. Looking out 10 days or 15 days per the statistic model suggests the active phase of the MJO is supposed to continue but slowly fall apart as the inactive phase works its way towards the West Pacific. The dynamic model, one could sort of, the ensemble GFS, suggests the active phase is to fade only in 5 days out, go dead neutral, and the inactive phase is supposed to push its way towards the dateline 15 days out. So the two models are kind of split at this point in time, but either outcome, either this or this sort of neutral outcome, neither of them suggests that the jet stream is going to be particularly well fueled for more than about a week or so, and then things are going to slowly decay. And that's sort of what the GFS model and the wave models all suggest too, that this gale that we have right now is probably the peak of the activity for a while, unless the MJO sort of regroups somehow. Let's take a look at long-term MJO projections. So here we go. So this chart's a little bit different. The date line, here we go, we got the, there, moved it. So here's the date line running right down the chart, but past history is down here moving to the future forecast. We see westerly wind burst number 5, I believe it was here, number 6 here back in the February time frame. But here we are, here's current right now. Basically a dead neutral pattern per the CFS model. And this is up at the 850 millibar level, 4,000 feet up. And it's a good proxy for what goes on down at the surface. Now let's overlay the MJO. Here's active phases of the MJO and westerly anomalies back in January time frame, then again in February. Here's the dotted line is the inactive phase of the MJO. That's right where we are now, but that should be fading out with the active phase, according to this, not even starting to make decent progress till about the end of March. But notice not a whole lot of westerly winds associated with this. The model had suggested stronger anomalies 3 weeks ago, but it has since backed off significantly and only given us just weak westerly anomalies, probably a little bit better than what we have now. But this also suggests that in the April time frame, the whole month of April, there should be westerly anomalies. Even though the inactive phase here starts making progress into the West Pacific, it's not going to, the westerly anomalies, mainly driven by the El Nino, will not give up on the date line until maybe about the end of April, and then the inactive phase takes over. Still weak westerly anomalies, but the expectation is with the change in season and the winter starting to wind down, storm production will become much more spottier, and if anything, really it's just going to be a weak gales, and it's take whatever you can get from about here on forward, especially noticing how the southern hemisphere is trying to come online already. So we've talked about west anomalies, and they would typically blow here. So this chart is depth profile, ocean temperatures going down depth, down to 500 meters, West Pacific here, East Pacific here. We see warm water here in the West Pacific, and working its way, but there was a bigger pocket here in the East Pacific associated with El Nino, but it is now fading out over the past week. But it's not so much the actual water temperatures, it's the anomalies, differences from normal. Now, at the peak of El Nino, we saw a big pocket over here in the 5 to 6 degree range plus. That's positive anomalies, and 4-degree anomalies out here, so pretty much from the date line eastward. But now you see we're down to 1-degree anomalies. Last week we had a pocket of 2-degree anomalies here and another here, and even some little 3-degree anomalies. That's all gone now. It's 1-degree anomalies and shallow. What is that? Maybe 75 meters deep at its peak, and now very shallow, only 25 or 30 meters deep here in the East Pacific, and steadily eroding. And the real noticeable thing is this pocket of cool water, which is steadily building. There was 3-degree anomalies here and a little pocket of 2 degrees a week ago. Now it's steady 2 degrees the whole way across and moving to, where is that? That is 110 west here, so that's like south of Mexico basically, and continuing to make eastward progress towards the Galapagos. And this pretty much, as this warm water basically moves off and dissipates, cool water is going to move in behind. That would be the beginning of some sort of La Nina. How strong, undetermined at this point in time, but it sort of looks like some sort of weak La Nina is imminent. And here's the high-res view, same sort of picture, West Pacific, East Pacific. It's a little bit more positive, suggesting was that 1, 2, 3, 1, 2, 2 to 3 degree anomalies still present here from about the date line over towards the Galapagos, with one little pocket here of 4-degree anomalies. But notice the cool water is also working its way to 110 west and digging in. It might just end up cutting this pocket off altogether and just start blooming here on the surface. And then so this is the leftover, a lot of this is leftover warm water from previous Kelvin waves advecting off to the west. This cool water will come here, cut off all this probably a month or so out. Cool water will emerge off the Galapagos. That'll be the beginning of what could be La Nina, and the last of the warm water will slowly travel off to the west and just dissipate in the Nino 3.4 region, and that'll be the end of our El Nino. Now, the practical effects of this is, even though the ocean surface and subsurface is changing, the atmosphere is still very much biased towards El Nino, because we've been in this sort of a forcing pattern since all of, at least half of 2014, all of 2015, and going well into 2016. So there's a lot of atmospheric momentum in play. That's not going to change immediately. Probably not till sometime almost next October, November, something like that. And of course, here's another chart. This is sea surface height or sea level anomalies. Take out all the waves, take out the tides, take out any wind bump, and where you see pockets of higher than normal heights, in this case 10 centimeters, 15 centimeters, 10 centimeters above normal. That suggests warm water at depth. Warm water, of course, expands, so it sort of pushes the surface waters up a little bit. But notice here, compared to last week, this had a lot more height under it. Now it's dead neutral in the main El Nino region. Here's the Galapagos, so 5 degrees north and south, so you can draw a box pretty much like right in here. And we see no anomalies, and that really speaks to the shallowness of the worm pool here. It's all at the surface and just sort of drifting off to the west. There's nothing left at depth per the Jason 2 satellite. And the chart here is upper 300 meters of the ocean's heat anomalies. You can see Kelvin waves, successive 1, 2, 3, 4, in this case 5 Kelvin waves through February, and then now notice what's happening. You don't see this pattern anywhere else. Complete collapse of subsurface warm temperatures. You see cool water that we were talking about in the upper 300 meters of the ocean starting to work its way off to the east. This clearly is not the upwelling phase of the Kelvin wave cycle, but looks to be a complete collapse of the subsurface warm pool. Completely expected for this time of year and this point in the El Nino life cycle. So we've talked about surface level westerly wind anomalies. We've talked about Kelvin waves and subsurface warm pool in this area. Now we're looking at actual surface temperatures in the ocean. And we still see anomalies here in the 2 to 3 degree range around the Galapagos off of Peru. And another little pocket here out towards the dateline. But you can see cooler anomalies, not as warm as it was right in here and a little bit here. Nothing super noticeable, just steady decay, if you will. We'll zoom in a little bit. This is the high res, and notice here pocket of cool water off of Colombia here. Here's Ecuador. There's still warm anomalies, little stray pockets of 2 1/4 right there. There's 2 1/4 degree anomalies, but looking much less intense than it was even 2 weeks ago. And notice cool water starting to show up along the coast here. And this is the last little pocket out in here of the really warm waters from the Galapagos out to about 110 west, and that is steadily eroding. The Nino 3.4 region, the main area for monitoring El Nino, is out here from 120 west out towards the dateline, and temps continued just this whole region right here dropping off significantly even from last week. This again pretty much just shows the demise of El Nino. And a little bit closer view, here's actual temperatures. This is another way to look at it from the TAO buoy array. You can't really argue with hard sensors on the ocean surface rather than satellite data. And one pocket of 1.5 degree anomalies from about the dateline to point south of Hawaii, roughly. Another pocket of 1.5 degree anomalies from south of California to about the Galapagos, with one little embedded 2 degree pocket. All this was up in 2.5 degree anomalies at the peak of El Nino. And notice it's all starting to get fragmented and broken up, and we expect that pattern to continue. The 7-day trend here shows it very clearly. Cooling, the blues are cooling than normal over the past, or cooling compared to 7 days ago, right here along the Galapagos and up here off Colombia. Another pocket here like we saw south of the U.S. West Coast almost to Hawaii. So cooling definitely in development. We can see that trend. Here's the Nino 1.2 area between the Galapagos and Ecuador. Steady downward shift in temperatures. A little bit of an uptick the past week. Was that 1, 2, 3, 4, 5? Yeah, 6 days, but still 1 degree above normal. Nothing very impressive. The Nino 3 region also showing a slow decline with the current value at plus 1.6. Still, that's well above normal. El Nino is 0.5 degree. If you can sit at 0.5 degree for 3 months, you're in El Nino. We're well above that still. So, though we're all sort of doom and gloom here talking about the demise of El Nino, temperatures are still well above normal. And of course, that has a significant atmospheric impact, or it should. And then the Nino 3.4 region, this is the main area, again, from 120 west out to about the dateline that NOAA is concerned with for declaring El Nino, was up at nearly 3 degrees back in January. It's down to about plus 1.6 degrees, still well above El Nino thresholds. But the real key here is that NOAA has, well, actually, we'll just go back, boom, boom, and we'll make that a little bit bigger here. Here we go. So the Nino 1.2 region, as you can see, never really got particularly warm from this El Nino event. Oops. But if you go to the Nino 3.4 region, that's where all the heat was, right here. But the past El Ninos, the super El Nino of 97, 98, and 82, 83, all the Nino regions were choking with warm water. And in fact, the balance of the warm water was in the Nino 1.2 region, though officially NOAA was monitoring the Nino 3.4 region. What we've learned from this El Nino, and I'm sure at some point NOAA is going to come back and redo how they calculate the relative strength of El Nino. But just because you have warm temperatures in Nino 3.4 and you don't have temperatures in Nino 1.2, that does not guarantee you're going to get exceptional rainfall into California. Northern California is about normal. Southern California is still in drought mode. I think that kind of puts the icing on the cake in terms of that. So Anyway, a more holistic view of El Nino is probably required when trying to calculate water impacts into California. So you can have westerly wind bursts, you can have Kelvin waves, you can have all the warm water in the world, but it doesn't make any difference if it doesn't have an impact on the atmosphere. And on the atmosphere, we're talking at a global level. One way, they call that atmospheric coupling. El Nino's atmospheric coupling, the ocean and the atmosphere. One way to measure that is the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Negative numbers suggest the active phase of the MJO, and clearly we have a little bit of that as of the daily status. Now we're down to minus 21.20. But notice here, so here was an active phase of the MJO wrapping up in early March. Mid-March, inactive phase, positive numbers here. And now here we go, we're starting to get into a run of negative numbers. The 30-day running average, minus 8.31, still rising, but that's because these numbers haven't really quite started working their way into the mix yet. Now, the 90-day running average, the good way to measure El Nino's strength, we're still at minus 15.97. When we're at minus 18, which we have been at times, that's a really strong El Nino. So the point being here is, though we have these ebbs and flows of the active and inactive phase of the MJO and the water temperatures crashing and all that, the atmosphere still thinks El Nino's in play and is still pretty well coupled. It sort of lags for a bit, and that's a good thing. That means that the storm system, the storm track, storm cycle, or support for enhanced storm development is not over by any means yet. Here's the 30-day running average graphed out. You can see the active phase of the MJO, inactive, and you can see the cycles as it goes through. More recently, so here we are right now. This is the inactive phase of the MJO, and we're still waiting to see the active phase starting to pull these numbers down. They'll go down for a bit, but based on the models and everything, this active phase is not expected to be very strong. Notice how you get some of these inactive phases like this that are sort of like not really much of an active phase. There's another one. Well, no, mainly that's probably a good example, and you see some of this around in here where it doesn't have as big of a spike as some of these other ones. We expect this one to probably be pretty weak. And another measure, Espi Index, same thing as the Southern Oscillation Index, only it's measuring differences in rainfall between the area north of Darwin and the larger area north of Tahiti. You can see the latest rainfall anomalies for the last 30 days. Still quite wet here north of Tahiti and pretty dry north of Darwin. The current index is 1.0. I think we were up in the 2.4 or even higher at the peak of this event. But still, normally by this point in time, this number should actually be lower than what it is. So this El Nino is hanging on still pretty well. So to wrap things up real quick right now, one gale over the date line, falling southeast towards Hawaii, going to generate raw, larger swell, probably swell number 13 for the season, and this will be for Hawaii, significant class swell, but pretty stormy is the expectation. Much smaller sideband swell for the U.S. West Coast. Tiny southern hemi swell probably working its way up into Southern California for the week. Looking longer term, MJO is active, but only over the West Pacific and kind of weak there. We see it in the jet stream. That's what's supporting the the gale that's over the date line right now. But it's supposed to slowly ease east and fall apart. Whether it will actually help pull the jet stream together off the U.S. West Coast and bring a little bit more rain into the Sierra and California, still to be determined, but whatever does happen will probably be pretty much on the weak side. We're in the active phase is coming up, supposed to actually go per the CFS model for the whole month of April. So whatever active phase we're having right now might be a false start. The models are all kind of confused. That tends to suggest a rather weak MJO signal when none of the models are in agreement, and that could be the case for the coming month. So that suggests a weaker storm pattern, both in terms of swell and snow. So take what you can get. We are in the springtime season now. Things are moving towards summer, so it's normal to expect the storm track to start to putter out now. But get what you can, make the most of it. We'll do this again next week, same time, same channel. Thanks for watching. Appreciate it.